Okay, today we'll be looking at parallel and series connection of resistors. In our previous class, we talked about Ohm's law. And we say that Ohm's law, V is equal to IR. That is the current passing through a metallic conductor at constant temperature is directly proportional to its potential difference. V stands for the potential difference. This is the current and this is the resistance. We have defined these parameters. And from here, we can say that I is equal to V all over R. And we can also say that R is equal to V all over I. It means from Ohm's law, you can calculate potential difference, you can calculate current, you can calculate resistance. We have explained this. So today we're looking at how we can calculate resistance connected in parallel and series. So let's look at it. What do we mean by series connection of the resistors? This is the circuit symbol of a resistor. Assuming this is R1, R2, R3 connected through a source. So the current passing through resistor 1 is the same as the same current that will pass through resistor 2 and is the same current that will pass through resistor 3. Whereas the potential difference for R1 is different, potential difference for R2 is different, and potential difference for R3 is different. So it means that if you are to measure the potential difference, you need to connect the voltmeter parallel to the resistor. So what I want you to know here is that when resistors are connected in series, the current passing through each of them is the same or common, but the potential difference will be different. So it means that from Ohm's law, we have that V is equal to IR. V, like I said, stands for the potential difference. I is the current and R is the resistance. So we can say that IR is equal to IR1 because the same current that will pass through this plus IR2, the same current plus IR3. So when you look at this, I is common. So we can factorize. We can say that IR will now be equal to I into R1 plus R2 plus R3. So this is the left-hand side of the equation. This is the right-hand side. Whatever you do to the left-hand side, you must also do it to the what? Right-hand side. So I is common on the left-hand side. And I is also common on the right-hand side of this equation. So we can cancel them. And we can say that R becomes R1 plus R2 plus R3. And this is the formula for calculating the equivalent resistance when resistors are connected in series. I always want students to know how these formula are derived. So if you are asked to calculate the total resistance or equivalent resistance, this is the formula we're going to use. So let's also look at the case where they are connected in parallel arrangement. This is the same disk, resistor 1, resistor 3. This is R1, R2, R3. Connected in parallel. This is a parallel connection. So in this case, the current passing through the individual resistor is different. We have I1 at this point, I2, I3. But the potential difference is common. The potential difference is common. So the same Ohm's law, we say that V is equal to IR, and we can say that I will be equal to V all over R. So from here, we can say that V over R is equal to, since the voltage is common for each of them, have V all over R1 plus V all over R2 plus V all over R3. So we can also write this, if you have something like this, V all over R, we can write it as V times 1 all over R. So since we can write this way, we can also say that V into 1 all over R is equal to, the V is common, so we can write this as V into 1 all over R1 plus 1 all over R2 plus 1 all over R3. So like I said earlier, this is the left-hand side, this is the right-hand side, and V is common. So we can easily cancel them. I'll say 1 all over R is equal to 1 over R1 plus 1 over R2 plus 1 all over R3. So this is the formula to calculate the equivalent resistance when they are connected in parallel. So don't always confuse capacitance and resistors. Let me refresh your memory. For the case of capacitors connected in series, we have done this before. The formula is 1 over C equal to 1 over C1 plus 1 over C2 plus 1 all over C3. But when they are connected in parallel, you have C will be equal to 1 C1 plus C2 plus C3. So don't always confuse capacitors and resistors. Capacitors, when they are connected in series, this is the formula. When they are connected in parallel, this is the formula. So for resistors, these are the formula.